trig function without using a calculator, and we're going to show our work. And the way I'm going to do this is I'm going to use reference angles. So I'm going to draw a unit circle, which I suppose I'm going to copy. I'll just repeatedly copy that and paste that. So I should probably draw a good one the first time around if I'm going to keep using it. And so here's X and here's Y. And so let me just take this and duplicate it maybe a few times here. So I draw a unit circle, and that's our approach here. I mean, one way is to just draw a unit circle once and just look at that. I could do that. Okay, but let's just then look at sine of 5, 6. Okay, the way I do this is I start off with referring to the x-axis, and I just labeled pi, but I'm going to write that as 6, 6 pi. Now, the reference angle is going to be pi over 6, and the way it works is you just look at the denominator 5, 6, and that's the reference angle will be pi over 6. And I'm going to draw that, and so the reference angle is down here, pi over 6, and I see that why is it not below? Well, because 5, 6 plus 1, 6 makes 6, 6. So 5, 6 is right below that. And then the idea is that on top of that, we are going to memorize the coordinates. Now, how would I do that? Well, by the position of where this angle is for 5, 6 pi, I can see that the shift left is greater than the shift up. And so therefore, I'm going to have the numbers I memorized, rad 3 over 2 and 1/2. But the question, why I said the shift left is greater than the shift up, is because there's sometimes, there's a question of which order those come in. So which one comes first is the larger number, rad 3 over 2. Moreover, we have negative for that x coordinate because of the quadrant it's in. Now, sine is simply the 1/2, which is the y coordinate, because sine is the y coordinate. Now, another way to do this is to keep in mind that pi over 6 corresponds to the degree angle 30 degrees, and we can make a nice little handy right triangle there and use that sine as opposite over hypotenuse, and therefore it's equal to 1/2. Now that gives the sine of 30 degrees, which is sine of pi over 6, and I need to pay attention to which quadrant 5, 6 pi is and see whether I need to adjust that to make it positive or negative. But I didn't have to adjust in this case. Here, the reference angle is pi over 3, which is the same as 60 degrees, but I'm not going to switch everything to degrees. I'm going to refer to pi, and I'm going to write pi as 3/3 pi. And if I move ahead one more pi, I get 1 more pi over 3, I get 4/3 pi over down here, and I see that the shift left is less than the shift down. And so the coordinates are negative 1/2, negative rad 3 over 2, and cosine is maybe I'll switch up colors. Cosine is the x coordinate. Cosine is the x coordinate. And so it's negative 1/2. But also what I can do is another approach, which is a pretty good one, or at least popular among a lot of people, is they draw a reference triangle where I have the angle 60 degrees, hypotenuse 2, and the shorter side is 1, and the longer side is rad 3. And cosine 60 degrees is adjacent over hypotenuse, and that makes 1/2. But that's cosine of 60 degrees or cosine of pi over 3, but we adjust negative to make it negative 1/2 for the quadrant in which it lies. Now, for tangent 2/3 pi, the reference angle is pi over 3, and therefore what I can use is the exact same triangle. And so the point is, like, do I really even, maybe I can just refer to it over here, but I'll just draw it down here. Okay. And this time I really like using the triangle. Tangent 60 degrees is going to be opposite over adjacent, and we can see that's rad 3 over 1. So I like that little triangle because I find it easy dealing with fractions when I have tangent. Tangent is opposite over adjacent. Okay, but I still need to determine which quadrant, I did that wrong, which quadrant this angle lies in. If I have pi as 3/3 pi, so I write it with the denominator 3 because I'm doing 2/3 pi. I'm going to back up by a third. I back up by the reference angle, which is pi over 3 or 60 degrees. And I get 2/3 pi. And I see that in quadrant 2, x is positive and y is negative. Now, tangent of theta in general is y over x. So if y is negative and x is positive, I'm going to get that tangent is rad 3 and it's negative. Negative because of the quadrant in which it lies in. Now I have another little tip, which I don't know if anybody really cares for, but I think it works out just fine, is to notice that if tangent theta is y over x, that's actually going to be the slope. Tangent theta will be the slope of that line segment that passes through the origin. Now, what is useful is by knowing its slope is that if it's decreasing, which it is here, since the line is decreasing, I know therefore that the slope is negative. It's a decreasing line, so the slope is negative, so I know tangent is negative. So that's one good way to look at this. Okay, we're sort of cranking through this, got a lot of stuff going on here. Okay, again, we'll just pick out the reference angle. The reference angle is pi over 6, because we have 6 in the denominator, and that's 30 degrees. And so I could go to the top page, but maybe I'll just as fast, maybe let's just do it again. Here's 30 degrees, and the shorter side is 1. I have 2, the longer side is rad 3. And cosine theta is, or cosine 30 degrees is equal to adjacent over hypotenuse. So this is going to be rad 3 over 2. Now, secant 30 degrees is the reciprocal of that, and that's going to give 2 over rad 3. Now, where is this all sitting? Well, here's pi, and so I'll write 6 pi. And sorry, I'm sort of blanking. No, I don't want to put it there. I want to put it right there. Okay. Trying to get this to look good. Okay. And 6 pi. Because the quadrant it lies, it both cosine and sine are negative. So, and secant is the reciprocal of cosine. So secant 6 pi will have the same value as secant pi over 6 or secant 30 degrees, but it's negative because of the quadrant in which it lies. And then it's sort of up to us whether we want to go the extra and rationalize the denominator. Another approach, rather than drawing those, is triangles, which is sort of time-consuming and a little messy, is to know that the coordinates are negative rad 3 over 2, negative 1/2. And how do I know that? Because of the position of where 6 pi is. I'm moving more to the left than I am down, so I put the number larger in magnitude, rad 3 over 2, first. And sort of seems like I'm overdoing it on the, I haven't really shown any pi over 4s or anything. But, oh, here we go, cosecant. So I suppose I didn't really make it write down in any single place here, which I should, that secant is the reciprocal of cosine. So let me make sure the cos don't go. Well, cosecant 7/4 pi is the reciprocal of sine of 7/4 pi. The cos don't go. And now the reference angle is pi over 4, and this time I get to draw a different triangle, the 45, 45, 90 triangle, because pi over 4 in different units, and the units of degrees, is 45 degrees. and I'll write this as 1, 1, and rad 2. That's something we memorize. And we'll get that sine of 45 degrees, which is sine of pi over 4, is opposite over hypotenuse, which is 1 over rad 2. It's traditional to write that as rad 2 over 2. Now, let's look at where that all lies. Now, here is 2 pi, which is the same thing as in fourths, 8/4. Now, see, I'm always going to refer to the x-axis. So let's see, I have 7/4 pi. Is that closer to 4/4 or 8/4? Well, it's closer to 8/4, and the reference angle is pi over 4, which I can draw here. It's a 45-degree angle. And now, let's see, what else do I have there? Now, just by the nature of a 45-degree angle, the x and y coordinates are going to be exactly the same in magnitude, but y will be negative because of the quadrant in which it lies. And I'm sort of running out of space here, but actually, let me also point out, if sine of 45 degrees 1 over rad 2, I sort of don't even necessarily want to rationalize the denominator because I'm going to take the reciprocal, and I have cosecant 45 degrees is rad 2. It's the reciprocal. And the question then is, when I get to cosecant 7/4 pi, it'll have the same value, but it might be negative, and it is because the quadrant in which it lies. So maybe I should perhaps just show one more step, is that sine of 7/4 pi is going to be negative 1 over rad 2. And so finally, cosecant 7/4 pi is negative rad 2, which is the reciprocal of this piece, negative rad 2 over 2, the y coordinate on the unit circle. I mean, I'm sort of overdoing it. You sort of can either stick either to a triangle or a unit circle, but you don't really need to do both. But you do need to know which quadrant the angle lies. That was just a lot of stuff, right? Talking very fast, but it was sort of necessary to get through all those answers. Okay, and that will finish this video.